Welcome to Marine Tech Talk, a podcast about how Teledyne Marine's innovative technologies are enabling scientific discoveries and commercial tasks in the world's oceans and waterways. In this episode of Marine Tech Talk, we talk with Shea Quinn, the Slocum glider product line manager for Teledyne Webb Research. Learn about the Slocum glider's capabilities and the applications that have revolutionized marine research and data collection. The gliders, originally named after the legendary oceanographer Joshua Slocum, have been designed to navigate the ocean's depths with unmatched precision and efficiency. With their sophisticated sensors, they can gather vast amounts of data while traversing the oceans for months on end without the need for human intervention. Join us and listen in as Teledyne Webb Research's Shea Quinn talks tech. Teledyne Tech. Now, here's the host of Marine Tech Talk, Rhonda Moniz.
And I want to welcome everyone to this episode of Teledyne's Marine Tech Talk. And it's my pleasure to welcome Shea Quinn to this episode, which I'm pretty excited about. We talk with, hey, Shea.
Hey, Rhonda.
How's it going?
I'm doing well. How are you?
Fantastic. I'm excited to have you on the show, and I'll tell you why. Well, for a lot of reasons, but one of the main reasons is because, let me just tell the audience what you work at Teledyne, and you are the Slocum glider project manager, line manager, right? You're the product line manager.
Yes.
Okay. So that was a mouthful, Shea. That must be a long title on your business card.
We usually just say PLM. It's a lot quicker.
Oh, okay. PLM. I feel like I'm in the secret club now.
There you go.
So it's really cool to talk to somebody at Teledyne because, I talk to a lot of different people and clients love the product, and the Slocum gliders are used around the world for so many different applications. But I'm interested in all of that. But I want to start out with asking you a little bit about your background and what brought you to Teledyne.
Absolutely. Thanks again for having me on the show today. My background is I started my career working as an electrical engineer and then a systems engineer for another company. I've been working for about 13 or 14 years now, and primarily in the marine tech field. So I've always done work with subsea vehicles or subsea communications of some kind. So prior to working for Teledyne, I was working at another company doing subsea robotics, primarily ROVs and AUVs. But I am originally from Falmouth, Massachusetts, and I saw the opportunity here at Teledyne Marine a few years ago. I've been working here at Teledyne Marine for about 2.5 years now as the product line manager for the Slocum gliders. So prior to starting work here, I'd had very little interaction with gliders as a vehicle, a subsea vehicle, but since starting work at Teledyne, I've been very impressed on just the level of different fields that gliders can be used in and the kind of work that they do. And I've really enjoyed getting to know the glider community and the people who are involved in it, because it really is a unique group of users that kind of take advantage of this vehicle and the different fields that it can be used in. So, like I said, I've been here at Teledyne Marine for about 2.5 years now. I'm originally from Falmouth, Massachusetts, so it was great for me to feel like I could move back home and become a part of, this community again. And I'm really enjoying the work that I do here. So I'm happy to talk about it.
That's awesome. Well, yes, you brought up something about applications for Slocum gliders, which is really, there's so many cool applications out there, but two of my favorites are mammal monitoring and storm chasing. So let's start out with mammal monitoring. Can you tell us about that application and the Slocum glider and how the gliders are being used for mammal monitoring?
Absolutely. I think for any listeners out there who are not familiar with what the Slocum glider is or what a glider is in terms of an underwater vehicle, I'll give a quick explanation, but a glider is a type of AUV, a type of autonomous underwater vehicle. And what differentiates it from most other AUVs out there, which are driven through the water using batteries, and they have a propeller or some other thruster that guides them through the water. A glider uses what we call a buoyancy-driven engine, and what that means is that the engine that it uses, instead of propelling it through the water, what it does is change the internal volume of the vehicle. There's a bladder with oil that gets moved in or out of the vehicle by a pump, and what that does is change the internal volume of the vehicle, which makes the glider sink or float. As it's sinking or as it's floating, it changes its pitch to either be tilted downwards or tilted upwards. So it moves through the water in this, what we call a sawtooth pattern or a sawtooth path, where it's sinking and then floating, and it's really only using its motor, its pump, at the inflection points, at its deepest point and at the surface or right below the surface. As a result, it's extremely efficient. These vehicles, as opposed to most AUVs that are really only able to stay out for a few days or maybe a week at a time, these gliders can stay out and monitor an area for months or even over a year at a time. So what they're great for is persistent monitoring of an area. Also, because the way they travel is by going up and down through the water column, they're really designed to measure the water column itself. They're not necessarily designed for tracking a seafloor or doing a side scan sonar type work on the floor of a body of water. They're not really like an unmanned surface vehicle, which is tracking what's happening at the surface of the water. It's really talking about the entire mass of water in between the surface and the seafloor and what's happening in there. So you can imagine being able to take consistent measurements over the course of months at a time of an area in those, from the surface down to 1,000 meters, really gives the glider a very unique look at what's happening in an area from an oceanographic perspective.
Thank you for that explanation. Actually, that was a good explanation of how a glider works, and it's really cool technology. When you apply the, how it goes, it really does go up and down in the water column. How does that work with mammal monitoring? How is that different from an AUV, like we were saying, or a surface, an unmanned surface vessel? What does that technology bring to mammal monitoring?
So the way that mammal monitoring has been traditionally done, and this is something that's really important across quite a few industries. Obviously, there's an academic look at wanting to understand and study mammals, but for many commercial sides of things, in industries like wind farm building or oil and gas or shipping lanes, making sure that endangered mammals or any mammals stay safe through those areas and are not interfered with by humans doing their work is very important. And because a glider is able to stay in an area for a very long period of time, it allows it to be there and present, essentially sensing mammals, listening for mammals. And the way that our gliders are used in this field is something called passive acoustic monitoring. And what that is essentially a hydrophone, an underwater microphone, attached to the glider that uses a advanced system to listen for whale songs. There are algorithms that can help to detect certain species of whales, the songs or the clicks or whatever they make, and able to onboard identify that those sounds are from a specific species of whale. And then the next time that the glider surfaces, it's able to send data saying, I heard this species of whale or this many of this species of whale in this approximate area at this time. And what that does is allow for that data to be sent near real time shoreside to coordinate efforts to make sure that whatever is happening in that area can be shut down or diverted or whatever else to keep the whales safe. Traditionally, lookouts would have to, people with binoculars would have to be looking for whales in order to try to make sure that they stayed safe, or sometimes they'd even use aerial planes or other vehicles to look for whales, and that was the best option that they had. Very expensive options and not very cost-effective ways of looking for whales. Instead, having a glider in the water that's there for months at a time, slowly swimming in an area and just listening for whale songs can really help make sure that you don't miss a whale, even if it's deep underwater, that you're aware that they're there and you can make the corrective actions to keep them safe. So it's really a pretty unique system that we've been able to install on our glider to make sure that that's helpful.
And an important and timely system because, here off the coast of New England, we have, the first series of wind farms that are going up in the country, and everyone's kind of all eyes on this area because that's going to happen around the rest of the country offshore. Right. And you got to know where the whales are because of ship strikes, any type of construction that's going on. So there's a lot of variables, commercial fishing and a lot of other things that affect whales and where they're going and how they are kept safe. So it's really cool to be using that technology for mammal monitoring. Now, what about storm chasing and getting into storms and what kind of data is being collected in those circumstances and how is that used?
So gliders have been used for several years now as a way to help predict both the path, but even more so the intensity of storms. The way that this was discovered was almost by accident. We had some customers from Rutgers University using gliders down in the Caribbean area and on the east coast of the United States as hurricanes were coming through. And they didn't have the opportunity to recover their gliders prior to the storm blowing over them. And they realized after the fact that the data that they had gotten about the water column of the hurricane helped to predict the path and intensity of the hurricane after it passed, as it was before, during, and after it passed over. Traditionally, a lot of the prediction that had been done for hurricane path and intensity had been done with satellites and using the surface temperature of the oceans. But they were able to show that it's not just the surface temperature, it's all sorts of information about the entire water column, how different layers of water are moving, and the glider is able to detect that while it's underwater. And being able to look at those layers of water and how they're interacting with each other can show both where we think the hurricane is going to go and the intensity of that hurricane. So it was a very sort of a breakthrough in terms of that sort of storm monitoring. Since then, fleets of gliders are deployed every year, starting around this time at the beginning of, right now it's early May, but around this time through the end of the summer, when it's hurricane season on the east coast of the United States and in the Caribbean and the Gulf of Mexico, there's these fleets of gliders. I think last year there may have been over 60 gliders from various institutions, universities. It's a collaboration between various institutions, universities, government programs to get as many gliders out there as possible to share the data and to help predict, follow these storms essentially, and help push that data to the public to make sure that the safest decisions and the most well-informed decisions are made using that data. So, at this point now, NOAA, as they're predicting hurricanes or other storms coming through the area, they're still using satellites, they're still using water temperature data at the surface, they're still using their hurricane hunters, but a big part of their fleet now is gliders in the water, measuring that water column and understanding what's going on beneath the surface of the water and how that's going to affect the storm above.
That's really cool. So there's a bunch of different applications. I mean, mammal monitoring, storm chasing. I mean, that's getting data from hurricanes. I mean, that's really obviously cutting edge and getting out there. And that's, obviously very important data to collect too. And what are some other applications that you're seeing gliders being? I know there's the Department of Defense. You can't really talk much about what they're doing with it because their stuff is top secret. Obviously, there's always a military application. I don't know if you can talk about any of that, but that and some others that that you're seeing going on now too.
Of course. To touch on the military a bit, like you said, there are some military applications. We have one of our largest programs is through the United States Navy, and it's through NAVOceano, and that program is called the LBSG program. It uses a large fleet of gliders, and it's to collect oceanographic data. These vehicles, they are an oceanographic platform, and it's great because they can be used in many different ways. The Navy, they're just gathering as much oceanographic data as they can because understanding the ocean is key to their success. Right. I guess that's probably about as much as I'll say there.
Right. Yeah, I don't want you to disappear, Shea.
But I would say in terms of different fields that it's used in, it's really all fields of oceanography. There are customers of ours that use it from a physical oceanography standpoint, where they're, again, tracking those different layers of water and how those are interacting with each other. There's people who use it from a chemical oceanography standpoint, looking at the chemical composition of water and what's happening and pH levels and the rest. There's obviously a very large biological oceanography side of things as well. And then there's sort of the applied applications of those, for example, fisheries. We have quite a few customers who are using gliders to help in fisheries. There are customers that we have, another group within NOAA out of La Jolla in San Diego. They're using our gliders to they're installed with both an echo sounder to find masses of zooplankton, and then they have these specialized cameras on them that, as the glider is going through these masses of zooplankton, is actually able to take pictures or sort of silhouettes of these specific creatures at that level, and be able to identify them later, showing, hey, this is the approximate amount of zooplankton in this area. This is we're able to identify the specific species, and with that data, they're able to then say how that would affect certain fisheries, how that would affect the populations of fish and the rest in other areas. So it's very cool. There's been a lot of different fields that I've had to learn more about in terms of oceanography. Again, I'm an engineer. I was kind of more just doing electrical jobs and putting stuff together. Now I got the opportunity to learn about different fields within oceanography and how they're able to use this vehicle to accomplish what they're looking for.
It is really amazing, all the different applications and all the different uses and, what people are and institutions and scientists and what everyone's doing with the technology. It is really, really cool. And I know you have some new systems coming out. You mentioned commercial fishing, and I know I just spoke with someone that works in Alaska that's using the glider systems for their Alaskan crab fishing industry has collapsed, and so it's cutting edge technology. It's really cool things, but it's also really important projects and applications that the technology is being used for, because they're trying to figure out why is this massive I don't know if it's million or billion, but this massive fisheries that's collapsing and what's going on. Because, obviously we have the changes in climate and everything's being affected. And without these tools, it would be really a lot harder and a lot more expensive, because then you need ships and people and in remote and dangerous locations. And so these tools are advancing our knowledge in so many areas. Now, you have a new generation coming out, I think, too. So can you talk a little bit about what are some of the new things that are coming out in the gliders, the Slocum gliders and that
Absolutely.
division specifically?
We have, we've constantly been moving forward our technology in certain ways, improving upon existing technology that we have, and integrating new sensors that certain customers need, or other hardware that would help them gain the data that they need. One of the newer products that we are excited about that we hope to launch later this year is a new vehicle within the Slocum glider family called the Sentinel glider. The Sentinel glider is going to be an ultra long endurance glider. This particular glider is a larger diameter than our traditional glider. Our traditional gliders are about 8.5, I think, inches in diameter. This is a 13-inch diameter, and right now it's looking to be able to hold about 3.5 times as many batteries as our standard glider.
Wow.
So when you're talking about being able to persistence of monitoring in an area, it just increases it that much more. What we've noticed over time is that as people learn more about gliders and what they're able to do, everyone wants to try and install a new sensor on there, a new capability, and not all sensors are that low powered, which is fine. We can accommodate that, but it does sometimes shorten the overall length of a mission. If you have something with active acoustics like an echo sounder, you have something that's taking large data samples like a hydrophone, a passive acoustic monitoring system. Those are generally going to be using a lot more power than some smaller, more simple sensors like a CTD. And because of that, we've added options to have extended energy bays on our vehicles and the rest. But the Sentinel glider is sort of the next step in that evolution, where we're saying, here's a not longer vehicle, here's a fatter vehicle, and it's got more batteries in it, and it's got more areas to mount sensors, and it's got more volume, and it can be faster. It has dual thrusters on it if you need to get in and out of areas that have strong currents. And it's just something that is a bigger, beefier version of a glider that's going to be able to stay in places longer, going to have longer endurance so it can have longer missions, and then also still have the energy to power some significant sensors.
So it was right. So longer mission endurance and greater payload capacity.
That's correct.
Right.
We're seeing, especially as we've been working with some of our customers and partners, looking at industries like wind farms. We mentioned it earlier. There's a lot of interest in making sure that as these wind farms are going up, they're doing it the right way. And that involves monitoring those areas before, during, and after construction. And there's a lot of different things that people are interested in monitoring. Obviously, we talked about mammal monitoring, listening for whales and making sure they're protected. But people want to know about the chemical composition of the water. They want to know about the biological composition of the water, and making sure that over the course of construction and installation of these systems, that stays unchanged or is not harmed. But a lot of times the sensors that are required to do that kind of work, again, require a lot of energy. So having one system where you're able to put as many sensors as you need on there to really look for, take all the measurements you need at once kind of a thing is kind of where we're moving with this, knowing that if we have a glider that's able to take all those measurements and stay out there for a long period of time, it's going to make it easier for our customers and the end users to really get the data that they need.
It's pretty remarkable. The technology in general is really remarkable. And, I was just thinking, they're also starting to, there's so many things to do here, but they're also looking at other planets with bodies of liquid. I don't want to say water because I don't know if they know if it is or isn't, but I don't think it is. It's other types of liquid, of putting things like AUVs out there. I wonder if gliders, I guess, would be a natural part of that too, if it had somewhere to, I guess it would depend, obviously.
I would be happy to put a glider on another planet.
Wouldn't that be cool?
To do that.
I know.
Be,
I interviewed a couple of people. I wrote an article quite a few years ago now, and interviewed a gentleman at Woods Hole Oceanographic, and it was really cool that they're doing that stuff. And when you were talking, I was thinking, oh, maybe they'll use gliders too. Maybe they already are. I mean, I don't. That article I did was a few years ago, but it's just really cool technology, and it's amazing to be able to be out there collecting all that data, and being able to just really put it out there and let it do its job, kind of thing. And having that Sentinel coming out is really interesting. That it's for longer endurance and greater payload capacity is a big deal for people too. Now, if we can just figure out what to do with all that data management and storage and all that, we'd have it all figured out.
That's the next step.
Yeah.
No, I will say we haven't done any spaceships yet, but we actually just a few months ago did have our first ever successful air deployment of a glider.
I saw that.
A small project that we worked on with the Navy, and it was deploying the glider out of the back of one of their helicopters.
It was really cool.
It was. I will say it was pretty cool. I was able to work personally on that project.
Were you? I saw it on.
Well,
I just saw the video on LinkedIn. That's all I saw. But I thought that was really, really cool that they were doing that. I was trying to figure out, like, oh my God, what is this going to look like? And then that was a nice angle too, how they deployed it. So you got to work on that project. That's really interesting.
Yeah, it was one of the for some of our larger users like the Navy, they have many of these gliders that they need to deploy over long periods of time, and getting a research ship to the areas that they need to be in isn't always quick or easy. But being able to deploy via a aircraft is something that can really help at least deploy the gliders where they need to be in a timely fashion, and then they can fly around, do their mission, and you can direct them back to a pickup point. So it's, again, one other way that we're trying to increase our technology or just serve our customers in a way that works for the mission that they're doing.
And that's really pretty cool that you were able to be a part of that, because it's the first time that's ever been done. And, Teledyne's known for innovation. So there you go.
It was pretty fun. I was pretty proud of that project.
That's cool. Well, listen, Shea, it's been awesome chatting with you today and having you on the show. I really enjoyed hearing.
Thank you for having me.
Yeah, it's really been great. I enjoyed hearing it. I'm used to talking to the clients, and they're super excited about being in the field and using the technology. But it's always interesting to chat with Teledyne people and who are on the other side and working with all of these different clients and seeing all the different things they're using the technology for. So I appreciate you taking the time today to talk to us.
Of course, yes. Thank you very much for having me. This kind of stuff, I get really excited about it. I don't know if you can't tell, but I love talking about the gliders and what they're used for. And so thank you for giving me that opportunity to come on here and talk and spread the word.
Yeah, it was awesome chatting. Thanks, Shea. Take care.
Thank you.
Thanks for listening to the Marine Tech Talk podcast. For more information about the line of Teledyne Slocum gliders, you can visit www.teledynemarine.com. If you have any questions or comments about this episode, you can email marinetechtalk@teledyne.com. If you like this podcast, please be sure to subscribe on Apple Podcast or wherever you are listening to the show. That way, you will never miss an episode. Thank you for listening, and we will see you again next time.